car leaves New Orleans traveling 50 km per hour. An hour later, the second car travels 70 km per hour. How long did it take the second car to overtake the first one? So, first of all, we take in the first car is a 7 km per hour, but it starts 1 hour before the second car. So it means that the distance between the first car and the second car, the distance between the first car and second car is going to be about 50 kilometer, because if it's 50 kilometer per hour for 1 hour, the distance between them is going to be 50 kilometer. 50 kilometer. What does it mean? When the distance is 50 kilometer apart, then it's going to start the second car. So we already know from the three basic formulas for velocity from the previous video, when, for example, v is equal with the velocity is a distance over time, and we have a t, the time, is equal with the distance over velocity, and now the distance in relationship with the velocity and time is equal with v time t. We already know these formulas. Now what we have to know here. So the first car, it has one distance, which is going to be distance 1, plus the distance d, this is a distance 50 kilometer apart is going to be, is equal with the distance of a second car when starts a second car. Now d1 I can write with v1 time t. I'm writing for t because the time when they are going to the time when it's going to overtake the second car is going to be the same time for both cars. So that's why I'm writing with a t. I'm not writing with a sub with any indexes or sub 1 or sub 2 or whatever. And d2 I'm writing with a v2, again because the time is a constant for both of them at the time when they reach in that point. I am writing with a t. And now I have to solve it for the time, to find the time, how long it takes. It means the time. So both sides now I am subtracting by minus v1t. I'm subtracting by minus v1t because I want to solve this equation for t. Therefore, I want to solve this, that's why I want to isolate the t in one side. And d, if I'm subtracting this side by v1t, minus v1t is going to disappear, so it remains just t. But in this side, v2t minus v1t. So when I'm subtracting the second, vt minus v1, because of the right side is not making any change other than I am subtracting by minus v1t. But now here, because t is the same for both, I can factorize t, and d is equal with t times v2 minus v1 minus v1. And everything here I divide by v2 minus v1. When I divide everything by minus v2 minus v1, then just I am switching the size because of to look a little bit better, more beautiful, the equation. I am putting this t in the other side, and when I divide this right side with v2 minus v1. v2 minus v1 is going to simplify, so remain just t. That's why here is t. But when I divide d by v2 minus v1 is going to be, I'm just putting it on the right side. So d is going to be over v2 minus v1. So now I have all the given, and the given here are as follows. So d, the distance is 50 kilometer apart. Before those is 50 kilometer, the first car is further than second car when the second car starts, and is a 50. So let me write 50 here. But here v2 is a 70, so 70. This here 70 is a greater because the second car starts with 70 kilometer per hour. Is a 70 minus, and v1 is a 50 kilometer. So here is 50 kilometer is 50. And what's going to be here is going to be 50 divided by 70 minus 50 is 20. And here, as we see here, this 0 with this 0 can go away. And 5 divided by 2 is 2.5. 2.5. So the time is equal with 2.5 hours. So 2 hours and a half. 2.5 hours. So it means that the second car is going to overtake the first car after 2.5 hours. So this is the solution for this example.